Hi there and welcome back. In this video, we're going to be learning about if statements. If statements allow our programs to make decisions depending on a Boolean. Let's get started with a friend name. Let's say we've got a friend called Rolf, and we want to check whether the user's name is Rolf. So the first thing we have to do is ask the user for their name, and then we're going to start typing our first if statement. What we're going to do is we're going to start with the first keyword, if. The if keyword is followed by a space, and then we put the Boolean. If this Boolean is true, then we will execute some code. So if true, we will execute some code. So we're going to say, hello, friend. Now, of course, true is always true, so this if statement is always going to execute. So what we want to put it here instead of true is a Boolean condition that depends on our variables, one of which is something dynamic that the user types. That way, every time the user runs the program, they can type something different, and this if statement will behave in one way or another. What we're going to put here is if user underscore name equal friend. Now, whenever we run this program, the friend variable will equal to Rolf, and the username variable will equal to whatever the user types. Then we will compare them, and if this evaluates to true, the if statement will run this code here. If it evaluates to false, then the if statement will not run this code. Now, let's talk about the syntax of the if statement. First of all, we have the if keyword, then we have our Boolean, then we have this colon, which is necessary in the if statement at the end of the first line, and then we have the body of the if statement. Now, something very important about if statements is that they have to have spaces in front of each line. Usually we use 4 spaces in Python. That's important because if you want to add another thing inside the if statement, such as print this runs to, this also has 4 spaces in front of it, and therefore Python knows that both of these prints are inside the if statement, and they should run only if this evaluates to true. As soon as you eliminate those spaces and you type something else, this is no longer part of the if statement. It always runs because it's outside the if statement. So to recap, this if statement will run this code inside the body only if this is true, and these lines need to have some spacing so that Python knows that they are both inside the if statement. Then when you take away the spaces, Python knows that the if statement is terminated. Notice that you cannot do this because Python would give you an error. This follows a line that doesn't have spaces in front, so it's not part of the if statement, it's just a line with spaces in front, and Python won't like that. So make sure that all the lines that are inside the if statement have these spaces. As soon as you terminate the spaces, you terminate the if statement. Let's run this just to show you how it works. I'll type in Rolf, and you'll see the 3 things printed out. Hello, friend, this runs to, and this runs anyway. And now if I run it again and I type Bob, you'll see that this runs anyway is printed out. That's this line here. And these 2 lines don't get printed out because the username was not equal to the friend in this case. Now imagine you wanted to do something if the username is equal to the friend, such as print hello friend, and also something if they are not equal to one another, such as hello stranger. You could do something like this. You can do this, but it is a little bit verbose. There's a lot of typing involved, and there's a lot of similarities between these 2 statements. In fact, Python comes in with another keyword, the else keyword, that is precisely for this thing. This if statement is now called a compound if statement, or an if statement with 2 branches, and what happens is if this one is not true, it will jump to the else one. So if the username is not equal to the friend, this will be false, and we will jump here and we will print hello stranger. Let's run this, and I will type in Bob, and you'll see that hello stranger gets printed out. So what's happened here is that Python knows that these 2 statements are related because they come one after another without any other commands in between. What I mean by that is you've got this if statement, then you've got the body, and the next line without this spaces in front is the else. So Python can build a relationship between these two and say they're related. And then what happens is, if this is not true, we jump here. Notice that if you put anything else here, you're going to get problems. Now, Python does not know that this else is related to this if, and therefore it tells you that this is invalid Python code because it doesn't make sense to just have an else statement on its own. Earlier on in the course, we mentioned that we could turn any value into a Boolean by passing it through the bool function. For example, print bool of 5. Here we're giving 5 to the bool function by putting it inside the brackets, and then we're giving that to the print function to show it to the user. So if we run this, you'll see that true gets printed out, because bool of 5 is true. Bool of 0, for example, is false. So why is this important? Well, you can do if 5, then print something like this. What this means is that if you do this, by the way, this will always print out runs, because 5 is true when passed through bool. And behind the scenes, Python is always passing everything here through the bool function to check whether it evaluates to true or false. I just wanted to show you that the thing that you put in the if statement does not have to be a Boolean comparison. It can just be a value. For example, if we ask the user for their name, we can just say if name. Here, what we're doing is if the name evaluates to true, then we will print we know your name. Now this is interesting because if we print the bool of name, you will see that no matter what we type, such as Rolf, it evaluates to true. If we type something else, such as Bob, it evaluates to true. If we type something else, such as nothing, that's when it evaluates to false. So the bool of an empty string, i.e. if we don't type anything, is false. So this is one of these scenarios where putting the variable directly in the if statement can be useful. Simply, if we don't have a value for name, or if the name's value is an empty string, we don't run this. Imagine you've got this code and you have a list of your friends, Rolf, Bob, and Anne, and a list of your family members, Jen and Charlie. Now, we want to ask the user for their name and then print hello friend if they are one of your friends, hello family if they are one of your family members, or I don't know you if they are neither of them. We'll start by doing if user underscore name equal friends. Now here we've got a problem. Equal compares two things directly, and username is always going to be a string. That's what the input function always gives us. But friends is a list. So these two things are never going to be equal to one another just because they are not even the same type of data. So what we want to do is we want to use Python's keyword in. The in keyword checks for whether the username is a value contained within the friends collection. So if this is true, then we will print hello friend. Now, we want to check whether the username is in the family members. So you may be tempted to do something like if username in family. And then, of course, your else statement, where we print I don't know you. You may be tempted to do this, but alas, there is a problem. Let's run this program and I'll type Rolf. And now you can see that we get two things printed out, which is not ideal. We get hello friend, and then I don't know you. Clearly not the case. If we print hello friend, we must know this person. So here's what happened in the code. We have Rolf inside our friends list, but we don't have Rolf inside our family list. Then the username was Rolf, so Rolf in friends is true. So we printed hello friend. Now in an unrelated if statement, we checked whether the username was in family. So Rolf in family is false. So because these two if statements are related to one another, we jumped directly to the else and we printed I don't know you. So really what we want to do is we want to chain all of these if statements so that only one of them ever runs. Of course, Python comes with that too. Just type elif. What this means is if this, else if this, else that. So we will do if Rolf in friends, print hello friend. Otherwise, if the username is in family, print hello family. Otherwise, if neither of those were true, print I don't know you. Now if we run this and we type Rolf, you'll see that hello friend gets printed out and nothing else. Similarly, if we type here something like Smith, you'll see I don't know you. You can put as many elif statements as you want inside one of these chains, so you can have multiple of those if you wanted, and as many as you want. Of course, if they have the same comparison, then that's kind of pointless, but you can put as many of them as you want, and they get evaluated in order. So this one gets evaluated first, then this one, and so on. The first one that runs means that the others don't run. So if the username is in friends, these all get skipped. If the username is not in friends, then we will try this one. And if this is true, then this gets skipped. Finally, if none of them are true, then we run this. By the way, I wanted to say that these 4 spaces in front of the lines have a special name, and that is called indentation. I say that because you'll hear me say this more often, and also you may hear it when you're reading about code. The indentation is the spaces in front of a line that denote that this is inside a block. And in this case, the block in question is the if body. Usually we use 4 spaces for indentation in Python code, but you can use 2 if you want, or indeed any other number of spaces. However, 4 is the normal amount to use, and I would recommend that you use that. Many problems for beginner programmers in Python are caused by indentation. Just take special care when indenting your code and putting spaces in front of it or removing spaces from the front of it, as that can sometimes cause a bit of confusion and can cause some problems. That's everything for this video though. We've learned about if statements. Thank you for joining me, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about while loops. Loops in programming are used to repeat things a number of times. And there are 2 types of loops in Python. We've got while loops and we've got for loops. In this video, we'll learn about while loops. Let's start with a simple Boolean. We will have a variable called isLearning, and we will make it equal to true. So at the moment we are learning, so we can type while is_learning, print your learning. So this is our first while loop. What we've got here is the while keyword, and then very much like an if statement, we have a Boolean. And this can be a variable such as isLearning, which is true. It can be a comparison, it can be a number or anything else. Then we have the colon, which just like in the if statement signals the start of the body. And the body comes underneath that and is always indented with usually 4 spaces. And then we have the print statement. Again, just like the if statement, you can put multiple things in the body as long as they're all indented, and you can unindent a line in order to signal the end of the while loop. I must say at this point that if you just leave it like this, that's totally fine. Python knows that you've reached the end of the file, so that also terminates the while loop. But if you do want to add something else, you can do, as long as it's unindented. Now, what will happen if we run this while loop is something maybe unexpected. The while loop repeats this code in the body for as long as this condition is true. So, for how long will this condition be true? Well, here's the thing. This condition never changes. It's always true because we don't set it to anything else anywhere else. So if we run this, you will see that we're learning a lot, and we maybe don't want to do that. We do want to take a break every now and then. And you'll see that we've printed a lot of these you're learning, which is good. But what if we only wanted to run this a certain amount of times? Say, until the user told us that they're no longer learning. Well, in order to do that, in order to stop this loop from running at some point, we have to set isLearning to false. So if we do that like this, isLearning equal false, here's what will happen. We will start the loop. IsLearning is true. So we will run it at least once. We will print that you're learning, and then we will set isLearning to false. Then we go back to the top, and we will evaluate this again. Now we will check if it's true again. But it's not. It's false, so it will stop. And it will continue from after the while loop onwards. If it were true, it would just repeat over and over as you've seen. But because we set it to false the first time that we run it, it only runs once. Just like that. So what we'll do is instead, we will ask the user whether they're learning. We will say input, are you still learning? And we will run this. So now we'll see that you're learning at least once because isLearning is true initially. And then we ask the user whether they're still learning. Now, what do we have to type here in order to continue the loop? Well, anything will go, such as yes. That is because now isLearning is no longer true. Now isLearning is the string yes that we've typed. And if you remember from our if statements video, this gets passed through the bool function, and it evaluates to true when it's yes. The boolean of yes is true. But if we type an empty string, then the loop ends because we have terminated the loop. So maybe this is not what we want. Maybe what we want is to get some user input and then say that isLearning is equal to user input equal yes. And what happens here is that first of all we store the user's input into its own variable, and then we compare it with the string yes. If they are the same, then this will be true, and if they are not the same, then it will be false. And we put that into isLearning. So now, only if we type yes will the loop continue. Otherwise, if we type no, for example, the loop will end. This here is a very common way of doing user menus or running applications where users can repeat something multiple times. Here's an example of one such menu. The first thing we do in this program is we get the user's input and we ask them if they wish to run the program. Then we have our while loop, which checks that the user input variable is equal to yes. If it is, we will start the loop and we print that we're running. Then we ask for the user input again, exactly the same thing. And after that, we will go back to the start of the while loop and we will compare user input, which now has the new value, against yes. If they're still the same, then we run again and we ask again, and so on. This is how you can repeat a piece of code many times until a user tells you to stop. So when would you want to use a while loop? When you want to repeat something an undefined number of times. For example, until a user tells you to stop. You don't know how many times you're going to repeat it. You depend on the user's input. The for loop, on the other hand, will be used to repeat something a defined number of times. Let's learn about that in the next video. I'll see you there. Hi guys and welcome back. In this video we're going to learn about for loops. A for loop is used to repeat something a defined number of times. That is, when you know how many times you want to repeat it. But a for loop in Python has a slightly different way about it than in other programming languages. So if you're coming from a different programming language, this is more like a for each loop. And if you don't know what I'm talking about, don't worry, let's learn about it. First of all, I will start with a friends list, which has the names of my friends. And then we will create our for loop. What we want to do is we want to print the name of each friend separately into its own lines. So what we'll do is we will do for, that is the keyword that signals that we want to start a for loop, and then we will do friend in friends, print friend. So a few familiar things going on in here. We've got the colon, we've got the indented body of the loop, but we do have something a bit weird going on in this line. Friend in friends. We learned that this was a Boolean comparison earlier on, right? But what is friend? We've not defined this variable anywhere. And here's the thing, this is not a Boolean comparison. What's going on here is you're telling Python to give you a new variable called friend once for every friend. So we're saying friend will be the first element in friends. Then when the loop repeats again, friend will now be the second element in friends. Then friend will be the third element in friends, and so on. This is why it uses also the in keyword, but it means something different than if you use it anywhere else. In the for loop, you've got for, new variable, in list. And then you get one iteration of the loop or one repeat of the loop for every value in that list. Note that instead of lists, you can use tuples, you can use sets or dictionaries here, and that's totally fine. Those are all known as iterables because you can iterate over them. You can use them for exactly this. So this is well and good when you've got a few values and you want to do something to each of them. But if you want to repeat something, say 10 times, you can do something like elements equal 0 to 10. And then you can do for index, which is a new variable. You can call this whatever you want, by the way, in elements, and we will print index. What this is doing is now we're going to repeat this loop 10 times because there are 10 numbers here. So by running this, we will see that we get the numbers 0 to 9 printed out. So we are getting the numbers 0 to 9, but we don't have to print them out. We can print something else, like hello world. And we know that because there are 10 elements here, this loop will run 10 times, and therefore we will get 10 hello worlds. So what I'm trying to say here is that just because you are getting a variable for each element, you don't have to use it for anything. And usually, when you do something like this where you create a variable but you don't use it inside a loop, we often in Python give it the name of underscore. So we just call it underscore, and that usually signals to other Python programmers that you don't intend on using this variable for anything. You could, if you wanted to, because that's a valid variable name, but this signals that you don't want to. Of course, you can give it any other name you want, and that's fine. I will go back to for index in elements just because I think it's a little bit more readable for you guys. But instead of creating our own list of 10 elements, you can actually just do range 10. And this is pretty much the same thing in that it will also run 10 times. What range is doing behind the scenes, it is creating something similar to that 10 element list. But it comes with a few more powerful things, such as you can do 5, 10 inside range, and this will give you the numbers 5 to 10. So 5, 6, 7, 8, and 9. Or you can do something like 2, 20, and 3. And what this does is it gives you the numbers 2 to 19, but only every 3 numbers. So 2, 5, 8, 11, 14, 17. Now, these are just some of the things you can do with range, and I don't expect you to get much use out of them just now, but it is one of the reasons to use range over creating your own list of 10 elements. As well as shorter, it is also more convenient and more powerful. Imagine you've got a list of dictionaries where each dictionary contains the name and the grade of a student. You could do for student in students, and remember, what we've got here is the for keyword, the student, the new variable that we are creating every iteration, and in students, which is our list or our iterable. We can then get the name of each student by doing student name. Now remember, student is each of the values in the list. So that's the first time the loop runs, student will be this dictionary here. The second time it runs, student will be this dictionary here, and then it will be this one, and then this one. So by doing student name, what you're going to do is you're going to get the name key of this dictionary the first time the loop runs, and you're going to put that inside the variable name. The second time the loop runs, you're going to get the name property of this dictionary, and you're going to put that inside this variable. And then you're going to repeat that for this dictionary and this one too. Let's do the same with grade. And finally, let's use them for something. Let's run this, and you'll see that we can print this information much more nicely rather than just printing out a dictionary by using this for loop and saying Rolf has a grade of 90, 78, 180. So when do you want to use a for loop? When you want to repeat something a certain number of times and you know how many that is, or when you want to use each of the values of an iterable, such as a list, tuple, or set, or dictionary, and you want to do something once for each of the values. I hope you've learned something in this video. I know that we're looking at a lot of different bits of Python, and maybe right now you don't quite understand why they are all important. But very soon, everything's going to come together and we're going to be able to develop very useful programs just with the knowledge that we've got so far. So thanks for sticking with me. Hope you've enjoyed it, and I'll see you in the next video. Hi guys, and welcome back. In this video, we're going to learn about destructuring. Sounds complicated, but it's actually really straightforward, and it's going to come in really handy. It makes our programs much more easy to read. Imagine you've got a tuple of currencies. Remember, this is how we can create a tuple. You can put the brackets in here, or not if you don't want to. You can, just like you do currencies equal 0.8, 1.2, you can do USD, EUR equal currencies. And what this means is we're going to get the first value of the tuple and put it into a new variable called USD. And we're going to take the second value of the tuple and we're going to put it into a new variable called EUR. So you can imagine that 0.8 is the United States dollars conversion rate and 1.2 is the euro conversion rate from pounds, of course. So this is called destructuring. It is taking a tuple, such as our currencies tuple, and turning it into multiple variables by this method. It's particularly interesting when you've got something like a list of tuples. Say, a list where the elements are all your friends' names and ages. Rolf 25, Anne 37, Charlie 31, and Bob 22. Here we've got a list with 4 tuples, and each tuple has a name and an age. Traditionally, we could do something like this, for friend in friends, and we could print the friend. Now, if we run this, you'll see that Python prints out each of the tuples. However, using destructuring, we can take directly, instead of friend, the name and the age. And what Python does is, it says, okay, each friend is a tuple, so we can just take the name and the age as the first and second element of the tuple. And then you can print something like name and age. So this looks a little bit nicer, but of course we can use them inside an f-string if we prefer. And that will be even nicer. The reason I'm showing you this is because this stuff here, destructuring inside a for loop, is something we're going to use in future videos, and it also makes your programs easier to read. If you didn't do this, you would have to do for friend in friends, and then name age equal friend. Or, even worse, name equal friend 0 and age equal friend 1. These are all equivalent. I will just keep them here for you. So these are equivalent, but of course this is much longer, this is slightly shorter, and just putting that here is the shortest of them all, and also the most readable once you know what it means. You do have to know what it means before this makes any sense, of course, but when it does, you'll see that, okay, each element in friends has 2 values, name and age, and we can extract them from the tuples as we iterate. Again, that process is called destructuring, so I hope you've learned something. In the future, we'll make more use of this. Thanks for joining me, and I'll see you in the next video. Hi guys, and welcome back. In this video, we're going to learn about iterating over dictionaries. Just as we iterated over lists or tuples with the for loop, we can iterate over dictionaries. Imagine you've got a dictionary of your friend names to their ages, such that you can access friend ages Rolf to get 25, or friend ages Anne to get 37. You can do for name in friend ages. And again, this is a variable that we can name whatever we want, but I'm calling it name at this point. And you can print name. What happens when you do this is you are iterating over the dictionary's keys. So what you will get here is Rolf, Anne, Charlie, and Bob. The values 25, 37, 31, 22 will be ignored and won't be present anywhere in here. So if we run this, you'll see that you get the keys back. If you wanted the values, you could iterate over friend ages dot values. And then if we run this, now you'll get 25, 37, 31, and 22. So just the ages. Name, comma, age in friend ages dot items. And what you're going to get now is this tuple of names and ages that you can destructure into two variables directly here in the for loop, and you'll get the name and the age. This here is the most common way of iterating over a dictionary. Usually you'll either iterate over the keys only, or you will iterate over the key and the value by using dot items on your dictionary variable. This is great because it allows you to get both the key, in case you want to show the key information when you're printing it out, and also the value. Remember that if this value is a list or another dictionary or a tuple, you will still get it in here, just the entire list or dictionary or tuple. So anything that is here will be age, and the key will be name. So this is iteration over dictionaries, and that's why I introduced to you tuple destructuring earlier on in the course. Thanks for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about break and continue, two more Python keywords that do some very interesting things when you put them inside a loop. Imagine you've got a list of car productions, so most of them are okay, but every now and then you get a faulty one. So what we want to do is we want to show the user that we are okay with most cars, but when we encounter a faulty one, we want to stop the production line entirely so that we have time to investigate. What we'll do is we will first of all iterate over this list. Now we can print something like this car is status. So this will just print each status. This car is okay, this car is okay, this car is okay, this car is faulty, this car is okay, this car is okay. Now, we've got a problem, which is that in our production line, or in our imaginary production line, when we encounter a faulty car, we cannot continue processing cars. So we have to stop the loop when that happens. Well, that's where the break keyword comes into play. Inside our for loop, we will have an if statement, and that will check if the status is faulty. Now, do note something very important. You've got a lot of spaces now because you need 4 spaces to tell Python that this line here is inside the for loop, and then you need an extra 4 spaces to tell it that it's inside the if statement. So you've got 8 spaces in total in this line here because it's both inside the for loop and the if statement. So if we encounter a car whose status is faulty, we're going to print stopping the production line. And then we're going to break. What this means is stop the loop. So because we are inside a loop here, break will stop it. No more iterations of the loop. We will simply continue from after the loop onwards. Let's run this. And you'll see that we get this car is okay, this car is okay, this car is okay, and then stopping the production line. So break is useful for when you want to terminate a loop completely. However, let's say that instead of completely stopping the production line, we just want to skip this car. For example, because every time that a car is okay, we ship it, shipping new car to customer. Every time a car is okay, we ship the new car to the customer. So if we run this right now, you'll see that we get this car is okay, shipping new car to customer. This car is okay, shipping new car to customer, and again, and finally we stop the production line because we found a faulty one. But again, what we want to do now is if we find a faulty one, we just want to skip it and ship the next one. So we can do that with a continue keyword. Instead of stopping the production line, we will type found faulty car, skipping, and then instead of break, we will do continue. And what this does is it just jumps back to the start of the loop without printing anything else or without running any other lines of code inside this loop. So when you encounter a continue keyword, it just goes into the next one from the top. So by pressing run again, you'll see that when we encounter the faulty car, we do not print this car is okay, shipping new car to customer. In total, we have 5 shipments because we have 5 OKs. All right, so those are the 2 keywords. And again, when you first start learning about a new piece of syntax like break and continue, you may not immediately understand what it's for, why it's useful. But we're going to learn through examples as we progress through the course. So don't worry about it. Thanks for joining me, and I'll see you in the next video. Hi guys, and welcome back. In this video, we're going to learn about the else keyword that we've used previously with if statements, but now we're going to use it with a loop. Let's look at this code that you saw in the last video. We've got our cars, which is a list of strings. It contains multiple OK strings and then a faulty one. Then we've got a for loop where we iterate for status in cars. And then if the status is faulty, we're going to print stopping the production line, or we're going to break. So in this case, when we encounter the break keyword, we completely terminate the loop. Then, if it wasn't faulty, we're going to print that this car is okay, and we're going to ship it away to the customer. Imagine you wanted to print something out if all of the cars were shipped successfully. Because at the moment, you're going to print something out when you find a faulty one, but you can't print something out when there are no faulty ones. A naive approach, something that a new programmer might do, might say all successful is true. And then, if a car status is faulty, then you set it to false. All successful is false, because clearly one of them was faulty. So you set all successful to false, and now after the loop, you can say if all successful, then print all cars built successfully. No faulty cars. This would be a naive approach, or an approach that involves a lot of coding in order to not use something that's already built into the language. What we do here is we set a variable to true, and then only when we encounter a problem do we set it to false, then we break, and then after the loop, if they were all successful, i.e. we did not break, we did not encounter a faulty car, then we print that they were all built successfully. But actually, the loops in Python already come with something like this. There is a way to run a piece of code if the loop did not encounter a break. And that is actually the else keyword that we've seen before. Now we've got the for loop, then the for loop body, and then this else statement directly in the same indentation level as the for loop, which tells Python that they are related. Remember, it's the same thing for if statements, but now the else is in the same line as the for loop. And what this means in Python is that if the loop completely ran through all of the elements without encountering a break or an error, then we run this code here. That's what it means. So we no longer need this variable here. We can just do this. And you'll see that nothing gets printed out. All cars built successfully, no faulty cars, does not appear because we stopped the production line halfway through. But if we remove the faulty, then you'll see that all cars were built successfully, no faulty cars. So the else keyword can actually be applied to loops, both the for loop and the while loop, and it means that this code here will run if the loop runs to completion, i.e. there are no breaks and no errors. This is actually something that not a lot of people know, that you can use the else keyword on loops, but it can save you quite a few lines of code and it can make your code a bit easier to read as well. So I hope you've learned something in this video. Thank you for joining me, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn more about for loops by creating a mathematical program that finds prime numbers. Let's start off by finding the prime numbers under the number 10. So we will do for n in range 2 to 10. And that means that we're going to get a new variable n, and it's going to be equal to 2 the first time that the loop runs, then it will be 3 the second time it runs, and then 4, and so on up until 9. We're going to start at 2 because it is the first prime number. Now, how do you check whether a number is prime or not? What you want to do is you want to see whether n is divisible by any number other than itself. So, how do we do that? Well, if n is 2, we know that it's a prime number because 2 is only divisible by 1 and 2. If n is 3, well, what we could do is we could check whether n is divisible by 2. And if it's not, then we know it's a prime number. So why is that? Well, imagine the number 3. There are only 2 numbers underneath it, 1 and 2. And we know that a prime number can only be divisible by 1 or itself in order to be prime. So the only number we have to check is 2. If 3 is not divisible by 2, we know it's a prime number. Let's move on to 4. For the number 4, we only have to check numbers 2 and 3. If 4 is divisible by 2, then we know that it's not prime. So for every number under the number we want to check, we need to see whether it's divisible or not. So what we're going to do is we're going to create another for loop that actually goes from 2 up to the number n. Remember, imagine we wanted to check whether 4 is prime, then we would check 2 and 3. If we wanted to check 8, then we would check 2, 3, 4, 5, 6, and 7. And what we do inside this inner loop is we say if n modulus x is 0, that means n divided by x gives you a remainder of 0, then we can print something like n equals x multiplied by n divided by x. And then we'll break. What this is doing is, imagine we are at iteration number 4. We will then start at 2, and we will say if 4 divided by 2 gives you a remainder of 0, then print 4 equals 2 times 2. And then we will break. Notice that the break keyword is inside 2 for loops. The break keyword and the continue keyword only affect the closest for loop to them. So only this loop would break. This loop here would not break. So what does this mean? Well, as soon as we find that n is divisible by x, that means that we know that n is not a prime number. So we don't have to check any more numbers. All we have to do is print that it equals something that can be divided, so it's not a prime number. However, imagine we've got iteration number 5. We will start with x is 2, and the remainder will not be 0, so we will not run this code. Then 5 divided by 3 will also not give you a remainder of 0, so we will also not run this code. Finally, 5 divided by 4 will also not cause to run this code. So, when the number is prime, this loop here will never break. Therefore, we can put an else keyword in this loop, which means if this loop runs to completion without encountering any breaks, n is prime. Let's run this, and you'll see the output. It's quite magical. You get 2 is a prime number, 3 is a prime number, 4 equals 2 times 2. Something interesting about this is you can see that as soon as we encounter one thing that it is divisible by, then we break, and we don't have to check whether 9 is divisible by 4, and then whether 9 is divisible by 5, and by 6, and by 7. As soon as we encounter that 9 is divisible by 3, we just stop, and that's it. So this here is actually quite a convoluted piece of code because you've got a nested for loop, and you're also making use of this else keyword that, again, most people don't know about. But hopefully it makes sense, and if you have any questions, please do ask in the course Q&A. As a small optimization, in case that you get asked in an interview or something like that, you don't have to check this loop from 2 to n. You actually, mathematically, only have to check from 2 to the square root of n. That's just how finding prime numbers works using Eratosthenes' sieve, but again, it's not really important for this code. Thank you for joining me in this video. I hope you've learned something, and I'll see you in the next one. Hi guys, and welcome back. In this video, I wanted to tell you about slicing. Slicing is the process of getting a part of a list or other iterable. Imagine you've got a list of your friends, and you wanted your friends between 2 and 4. You can do print, friends, and then in square brackets, 2:4. And what this means is you're going to get Anna and Bob. That's 2, 3, and stops at 4, so it doesn't get you 4. This here is list slicing, and you can do this with strings as well if you want, or with tuples, and what it allows you to do is to get a segment of a list, or tuple, or a string. It can be really useful at times, but it is particularly useful because you can actually skip some of these numbers. For example, if you want to only get elements in the list except the first one, you can do 1:nothing. And what that means is 1 to the end of the list. So if you do this, you're going to get all your friends except the first one. Similarly, if you put 4 in here, it will start at the very start of the list, end at 4. So we will get Rolf, Charlie, Anna, and Bob, and we will skip the 4th one and any later ones as well. Now, if you remove both numbers, so you just do colon inside square brackets, you'll actually get all the elements back, but with a key difference. You're not getting the same list. It is a new list that you're building. And at this point, that doesn't really matter. It doesn't have a lot of meaning to you, but it just gives you a new list, and this is the way to do that in Python. If you want a new list which contains all of the elements of the previous list, you can do this. If you just do this, you're just getting the same list, so exactly the same thing. Now, with list slicing, you can actually use negative numbers. For example, -3 up to the end of the list. And what this does is it starts counting from the end. So you will get back Anna, which is the element starting from the end, the third one, Bob and Jen. Because again, -3 is the starting point, and when you skip the ending point, that is the end of the list. So you could do -3 to 4, for example, and you get Anna and Bob because it stops at 4. Or you can do -3 empty, and then it'll run to the end of the list. You can do this here. So it will go from the start of the list, because you haven't put anything in there, up to the second to last element, Bob. So you get Rolf, Charlie, and Anna. This is useful if you wanted all your friends except the last 2, for example. Finally, you can also do -3 and, for example, -1. And again, that gives you from the third element from the end, Anna, up to the first element from the end, Jen, but it does not include this one, as always, so you just get Anna and Bob. There's a lot more stuff you can do with slices, but I just wanted to give you a very quick primer The first number is the starting point, and the second number is the ending point. We're going to link in the resources section of this lecture a few blog posts that we've written on list slicing. Some of them may be a bit advanced, but you can read them or bookmark them to come back to them in the future. And there's quite a lot of stuff you can do. They are very powerful tools in Python. Thanks for joining me in this video. I hope you've learned something, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about list comprehensions. List comprehensions are a feature of Python that allows us to create new lists very succinctly while also being very powerful. Let's say you've got a list of numbers and you want to create a new list which contains those numbers multiplied by 2. So you'd start with something like numbers equal, and the numbers from 0 to 4, say. And then you want doubled numbers to contain those numbers, but every number multiplied by 2. What you'd have to do without a list comprehension is you would have to use a for loop to go over each number in the numbers list. And then you would have to say doubled numbers dot append to add a new number to the doubled numbers list. And you can append number times 2. And then at the end you can print doubled numbers. So this would do what you want. If you run this, you'll see that the output is 0, 2, 4, 6, 8. Instead of doing this, you can use a list comprehension, which actually has similar syntax in many places, but it's much shorter, and once you're accustomed to it, it's also a little bit easier to read. How you do that is you would say doubled numbers equals, and then you start off with some brackets. You put here the value that you want to use in the new list, which would be number times 2. And then you put in something like what you see in a for loop. So this is a shorter way of doing exactly this piece of code here. You say, I want to put in my new list number times 2, where the number is each number in the numbers list. And the syntax for that is, again, inside square brackets, the value you want to create into the new list for the variable that you want to use in the list that you want to iterate over to create this new list. So again, it does exactly the same as this. You create your new list, iterate over the numbers list, and add the new number into the new list. So you can just delete this, and of course move the print statement underneath so that it exists when you print it, and the output is exactly the same. Now remember that instead of creating your own list of numbers, you can use range, so you can say in range 5. Now this is exactly the same. You're still creating your new number variable that only exists within this new list, and you are iterating from 0 to 5. And every iteration you're putting into the new list number times 2. Notice that here you can put whatever you want. So it doesn't have to be number times 2. It could just be 5 if you want. And then what you would get out would be 5, 5, 5, 5, because you are repeating 5 times, and the value you're putting each time is 5. If you want, you can go back to number times 2. But again, just wanted to tell you that anything goes in here. You don't have to use this variable. You can put whatever you want. And like I mentioned earlier on in the course, if you're not using the variable, you normally use the underscore for it to signal that you don't care about the variable in here. Let's say you've got a list with your friends' ages and you want to create a new list which contains a string describing your friend's age for each of your friends. So you could create something like age strings, and in here put an F string. My friend is age years old. Now you want to create this string for each element in this list. So you would say for age in friend ages. Let me just make this a bit bigger for you so you can see it in one line. So this is exactly the same structure as we had before. You've got your brackets that signal that you are creating a new list. And then because of what's inside it, you know it's a list comprehension. You've got this for loop there. And what you're putting into your new list is this string. My friend is age years old. and then you are creating the age variable that you're going to use for each of the values in your friend ages list. So you'd end up with one string for each age, where the age variable will be replaced into there. So you can print age strings. So you can see the output here is a list with 4 elements, 4 strings, one for each age. Now let's say you've got the names of some of your friends, like Rolf, Bob, and Jen. And what you want is to apply a transformation to each element so that you'll only get back lowercase letters. So Rolf will be turned to lowercase r, O, L, F, Bob will get a lowercase b, and Jen will get a lowercase j. What you can do is you can create a new list, which will be a list comprehension, and what you'll do here is name.lower, which actually can be used on any string to turn it into a lowercase string for name in names. And again, you create the name variable, which will be each of the strings inside the names list, and you're putting into your new list name.lower every iteration, which will give you lowercase Rolf, lowercase Bob, lowercase Jen. So if we print this out, you'll see the output there. This is particularly useful for when you want to work with user input. For example, let's say you've got a list of friend names and you want the user to give you their name so you can see if they are in the list. It's possible that the user will type lowercase or uppercase letters which don't exactly match these strings. So it can be useful to turn everything to lowercase when you're doing comparisons between your strings and user input. For example, something like this. You've got a friend variable, which is some user input. We ask them to enter their friend name. And then you've got a friends list, which contains a bunch of friends. If you want to see whether the user's input is in this list, you can do something like if friend in friends, print friend is one of your friends. So we can run this. And if we enter Rolf, say, then we'll get Rolf is one of your friends. But very often users will enter Rolf or maybe lowercase Rolf. Maybe they can't be bothered entering the capital R, or maybe their name is all in lowercase, as in some countries. That is what happens. So if we enter Rolf with a lowercase r, you'll see that nothing gets printed out, even though it probably should. So what to do is create a new list where each of the names is lowercase. So friends lower can be name.lower for name in friends. And then what we're going to do is compare friend against friends lower. But if we do this and run it as is, when we type Rolf with a capital R, it will no longer show as correct, because now we are comparing capital R Rolf with lowercase Rolf, which is in this list. So we also have to turn friend into lowercase in order to have a fair comparison. So we'll do if friend.lower in friends lower, then we will print out. This has a benefit, which is that now I can type Rolf with a capital R, and it says that it's one of my friends. But I can also type Rolf with a lowercase r, and that's also fine. Finally, I can type Rolf with any sort of upper or lowercase letters, and it will be correct. By the way, if you wanted to print this out with the usual capitalization, which is the R uppercase and the rest of the letters lowercase, then that's called title casing. And you can do that on the friend here by doing title. So here I've typed Rolf with all uppercase letters, but because we're printing friend.title, what that does is it turns it into the traditional title casing, which is that every word in the string will have the first letter as uppercase and the other letters as lowercase. So this can just be a small improvement, and of course you can put this into a separate variable if you prefer, just like that. So either goes, it's up to you. So that's it for this video. We have learned about list comprehensions, which, to recap, have a structure of the new value that you want to put into your list for the variable that you want to use for each iteration in the iterable that you want to go over. And this doesn't have to be a list, by the way. It could be a tuple or a set or anything else. In the next videos, we're going to learn a bit more about list comprehensions, including how to add conditionals to them to make them a bit more flexible. Thank you for joining me, and I'll see you in the next video. Hi guys, and welcome back. In this video, we're going to be learning about list comprehensions with conditionals, which we can use to filter out some elements while we're putting them into a new list using list comprehensions. So let's say you've got some ages of your friends and you want to get only the odd ages. You could do something like odds equal age for age in ages, and that is a list comprehension that puts the value age for age, which is the new variable you're creating, in the ages list. So it's going to put every age in the ages list into a new list that you're calling odds. What you can do is, if you wanted to get only the odd ages, you can actually put an if statement at the end, if age modulus 2 equal 1. And what this is going to do is it's going to put this value into the new list if this conditional is true. And if this conditional is false, then it's not going to put the value in. So if we run that, you'll see 35, 27, and 21, which are the odd ages in the original list. Now, I appreciate that as soon as you start putting conditionals into a list comprehension, it does get a little bit more cluttered because you have the for keyword, in keyword, and if keyword all in one line. So something you have to be careful with when you're writing list comprehensions is that if it's getting too long and too complicated, you can split things out and move them outside the list comprehension, or you can just use a normal for loop like we learned in the last video to add to a new list. That can reduce the cognitive load on your brain because it can make the code a bit easier to read. So list comprehensions are good when they are kept simple and they help your code, but if they're too complicated, they can actually detract from your code. Let's say you've got the names of some friends and they are in a mix of uppercase and lowercase spelling, and then you've got another list of guests that have come to one of your parties. We're going to turn every friend in our friends list into lowercase so that we can easily compare them with our guests. But if we wanted to compare, now let's say we want a final list of those friends that have come to your party. So there are two approaches. The first approach is that you can turn all of these guests into lowercase as well. So you can do guests lower equal g lower for g in guests. So now you have two lowercase lists. If you turn both of these into sets by actually passing them through the set function, then you could print the intersection of the two. So friends lower dot intersection with guests lower. And this would give you those friends that are here and also here, which are Charlie and Rolf. So this is one way to do it. But it's a bit more difficult to get these names out as capital C and capital R, because in the sets you've got them all as lowercase. So instead, we're not going to use sets for our approach, and we're going to use a list comprehension. We will create a present friends list. Because it's going to be a long list comprehension, I'm going to split it out into multiple lines. And you can do this, you can just put the square brackets in one line and in another, and in the middle you can write out your list comprehension. And what I'm going to do is I'm going to put the name for name in guests if the name.lower is in friends lower. And what this allows me to do is put each of the names of the guests inside my new list if that name turned to lowercase is in my friends lower list. And of course, instead of just name, I can do name.title. If we print this out, you'll see the output here, which is Rolf and Charlie. Another benefit of this that might be a benefit or it might be irrelevant for your program is that the output is in order of the guests, so Rolf and then Charlie. When you turn these into sets, they lose the order. So potentially if this order had some sort of meaning in your program, such as who arrived first or something like that, then you would get to keep that if you use lists, but you wouldn't get to keep that if you use sets. As an aside, here's something that you probably should never do, which is nest list comprehensions one inside of another. Here you've got friends lower, which you know is this list comprehension here, which turns each friend into their lowercase variant. But you actually don't have to define a variable. You can just copy it and paste it in there and delete this variable entirely. But as you can see, this is a very dangerous thing to be doing, because it quickly becomes unreadable. Splitting things out into variables is almost always the better choice, because it's going to make your code more readable. If you do have a long list comprehension where one line is not enough, you can split it further into something like this. It's usual to have the first line as the new thing that you want to put into your list. The second line as the iteration over an existing iterable, like this list. And finally, the comprehension, if there is one. Splitting list comprehensions in this way can be helpful to make your code a bit more readable, but it is a sign that it is getting a bit too long. So it's almost always better to put this here into a separate variable and either keep it in 3 lines or put it back into 1 line. That's it for this video though. I just wanted to show you that you can put if statements inside a list comprehension where it makes sense. Don't overcomplicate things. Writing simple code is almost always better than writing complicated code. Thanks for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video, I wanted to tell you about set and dictionary comprehensions. In the last video, we had a look at this code, where we have our friends list and our guests list. And in order to compare them both, we tried to turn them both into lowercase, and then pass them through sets, so that we could then print the intersection. And we did friends lower.intersection guests lower. However, we can just use set comprehensions instead of list comprehensions and then pass it through the set function. Just like we can do list comprehensions by using square brackets and then putting the thing we want to put into the new list for the iterating variable in the iterable, we can just do this. Instead of creating a new list first and then making a set out of it, we can just create a set straight away, and that is going to be faster and also a bit more readable. Let's do the same down here. Now, one of the problems we had in the last video with doing something like this is we weren't able to output the names in capitalized format. So we always had the lowercase names at the end because that's what we used to sort of compare them. But actually we can create a final set comprehension that does this for us. So what I've got here is a third set comprehension that puts the name turned into title case for the name in the intersection. Of course, it is easier if you take this out and put it into another variable, just like that. If we run this, you'll see that the output is now what we wanted. Though it is a little bit longer, it does have the extra benefit of removing any duplicate friends if there were any. So if somebody was in this list twice, for example, for some reason, either due to an error or maybe they RSVP'd twice or something like that, then this would get rid of that. However, it could also have the problem of removing duplicate elements. So if 2 people have the same name, you could end up with only one of those people showing up in these sets. Either way, I wanted to tell you that you can do set comprehensions, which is the same thing as a list comprehension, but using curly braces instead of square brackets, and you end up with a set at the end of it. Let's say you've got a list of friend names and how long ago since you last saw them, and you want to create a dictionary out of these 2. What you can do is you can create something like a variable called long timers, and once again, using curly braces, just as we do with dictionaries, you can do friends I, times since seen I. And what this does is it accesses the ith element of the friends list. So for example, if I was 0, it would access friends 0, and that's Rolf, and it would associate with that this value here, which is times since seen 0, which would be 3. So you could end up with Rolf 3. Now, if you repeat this for every index, so 0, 1, 2, and 3, you'd end up with a dictionary of the elements which include all of these in these 2 lists. So you could do for I in range of the length of friends. And what this means is you are creating a new variable called I And its values will range from 0, which is the start of the range function, up to the length of friends, which is 4. So it would go from 0 to 3 inclusive, and that would give you all of these. If we print this out and run it, you'll see what I mean. You get Rolf and 3, Bob and 7, Jen and 15, Anne and 11. One of the benefits of doing a list comprehension like this one is that if you were only interested in those people that you haven't seen for 5 days or more, you can of course put a conditional in here as we've seen. Something like that. So now you're only running this if the times since seen I, which would be the number that we're currently looking at, is greater than 5. So now you would only get Bob, Jen and Anne. Running this, you'll see that that is correct. So dictionary comprehension, which is this, works in exactly the same way as set comprehension in that you use the curly braces, but instead of putting a single value into the set comprehension, you put the key, colon, the value, just as we did with dictionaries before. Dictionary comprehension is used much less than other types of comprehension, but sometimes it can be really handy. So I just wanted to show it to you, tell you that it's possible, and maybe you'll encounter it in the future. Thank you for joining me in this video. I hope you've learned something, and I'll see you in the next one. Hi guys and welcome back. In this video I wanted to tell you about the zip function. In the last video we saw this code where we have our friends and how long ago we saw them, and let's say we wanted to create a dictionary of the friend names to the time since we last saw them. We saw how we could add a conditional here if we wanted to filter out friends that we hadn't seen for 5 days or more, but let's say that we don't want to do that. If you want to create a dictionary like this, you actually don't have to run this code. You can run something a bit simpler. If you manage to combine these two lists into one list with this format, where you got a pair of elements as each element of the list, then you can just pass this through the dict function as we've seen earlier on in the course in order to get a dictionary. But how do you combine these two lists into something like this? Well, that's where the zip function comes into play. You can do zip, friends and times since seen, and that is essentially going to run a zipper through both of these lists, closing them up and combining them into one list where each element of the new list is a tuple of elements. So that's going to be Rolf and 3, Bob and 7, Jen and 15, Anne and 11. So you can actually just use this code instead of this list comprehension, and it will be a little bit simpler, just like that. Notice that if we turn this into a list and print it out, you'll see that zip turns them into a list of tuples like this. As an interesting aside, if you just print out the result of calling zip, you won't see something like that. You'll see something a bit more confusing. We're going to be learning more about these things as we go through the course, but for now just know that zip essentially combines two lists or more into one list. I say or more because you can have more lists here if you want. So if we do something like this and turn it into a list, you'll see that now the tuples have 3 elements. Rolf 3, 1, Bob 7, 2, Jen 15, 3, and so on. Do note that this list was longer than these two lists. It has 5 elements instead of 4, but zip will just ignore any elements that don't match the other lists. So you will always end up with something like the shortest list. Thank you for joining me in this video. I hope you've learned something, and I'll see you in the next one. Hi guys and welcome back. In this video we're going to learn about the enumerate function. Like zip, we can use enumerate to turn a sequence, like a list or a tuple, into something new. There are some differences of course, so we're going to learn about them in this video. Let's get started. Here we've got a list of 3 friends. We learned that with zip we could join it with another list. However, enumerate is used to join this list with a number for each element. So, how can you get one number for each element? Let's say 0, 1, and 2. Imagine you want to loop over this list and you want to print out which is first, second, and third. At the moment, without the enumerate function, we would do something like this. This is going to give us each of the friends, and if we run that, you'll see that we get Rolf, John, and Anna, but we don't get a number for each. In order to get a number for each friend, we have to do something like index equal 0, then we have to print the index, and then here we have to say index is index plus 1. Now when we run it, we'll get 0 Rolf, 1 John, 2 Anna. Instead of index, which is a very overused variable name, I like to use counter instead, but it doesn't really matter, the logic remains the same. Now, the enumerate function is used to do this, but in a much more concise way, without having to keep track of a separate variable and incrementing it at the end. So, we're going to turn this code into some code that uses enumerate. I'll just do it down here so you guys can see the difference between the two pieces of code, and then I'll delete this one after. What you do is for counter, comma, friend in enumerate of friends, now you can do print counter, print friend. So now I'm going to run this and you'll see that the output of this code gets printed out first and then this code after. Okay, so you see 0 Rolf, 1 John, 2 Anna, and then the exact same thing, which means that the enumerate function gives us the two values, counter and friend, for each of the elements in the friends list. All right, I'm going to delete this now. And let me also show you what we get if we do a list of enumerate of friends. So now we're going to run this code again, and you'll see that we get the same output from the for loop, and then we get the list of enumerate, which is a list now of tuples, where each tuple has a number and the value from our list. You can think of this, if you like, as the same thing as doing this zip of 0, 1, and 2 and our friends list. So if we print the list of this, you'll see that the output is the same. That's essentially what the enumerate function is doing. Not quite, but it's close enough. So if that helps you remember what it does, then I hope that that's helpful. So enumerate is going to give us a number for each element in our list, and it's going to join them together so that we can then access them like that in the for loop. We can also pass this to the dictionary if we want, the dict function there. And then what that's going to do is it's going to turn these tuples into dictionary keys and values. So the output there is that the key 0 in this dictionary has a value of Rolf, and the key 1 has a value of John, and the key 2 has a value of Anna. By default, the enumerate function starts at 0, but you can tell it to start at 1, if you like, with this named argument. So if we say start equal 1, then you can run that and you'll get 1, 2, 3. Notice that these still start at 0 because we didn't call the enumerate function with the start argument. So you can use that if you want, or you can leave it out to start at 0. All right, that's really everything there is to the enumerate function. I'm going to leave a blog post linked in the resources section of this lecture for you to read if you want. It says basically the same thing that we've just covered in this video, but it may help you to see it in written form as well. Thanks for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video, we'll finally be learning about functions. We've been using functions such as print, len, or zip, but we haven't really learned how they work behind the scenes, or even how we can define our own. So that's what we're going to be looking at in this video. Let's create our first function. Functions always start with the def keyword. Just like if and for, def is a Python keyword, and after it you put a space, and what this tells Python is that you are about to define a function. So the next thing is the function name. For example, the print function is called print, len function is called len, so here you can name your function whatever you want. For example, greet. Afterwards, you have to put a pair of brackets, so that's an opening bracket and a closing bracket. Inside the brackets, you can put some stuff, but we're going to learn how to do that in a future video. After the brackets, the usual colon. And now, of course, we have an indented block, which will be the body of the function. Let me write some code in here and show you how functions operate. So I've written our usual code here that asks the user for their name and then prints hello name. This is the body of the function, and the function is called greet. If we run this code, such as by pressing the run button, Python would start running at line 1, and it would encounter this def keyword. When Python encounters a def keyword, it knows you want to define a new function, so it takes note of the name. In addition, if there was anything inside the brackets, it would also look at that, but there's nothing there for now. So Python knows the name of the new function that we've defined, and then Python instantly skips over the entire body. It does not run the body. So these lines here, if we run this program, never execute. Nothing happens. Nothing is printed out because they are inside the function. And what we've done in this piece of code is we have defined the function. We've created it. But now we need to run it. So we will say greet, just like that. And that runs your function. So if we press play, you'll now see enter your name, and we can enter anything we want, and then the print statement as well. You can put as much or as little code as you want inside a function, but you should prefer shorter functions over longer ones. That's because the longer your functions get, the more jumping around you're going to see in your programs, and it's going to be a bit more difficult to read. And remember, you can always create more functions. Just make sure to unindent and put another def statement if you want to create another function. Functions can call other functions. Calling is the same as executing, so you can always define a function and call it from here, and then you can define another one and call it somewhere else, and so on. Something important is that you can only call a function after it's been defined, but not before. So if I move the greet to line 1, say, now we will get an error because it doesn't know what greet is until after it's run the def statement. Finally, if you try to do something like print name, which is the variable that we defined inside the function, you will get an error. So let's try that out. You get an error that says that the name, which is our variable, is not defined. Although it was defined inside the function, and we actually ran the function, variables created inside a function die when they reach the end of the function. So you can create variables in here that will only be used within the function itself. Alright, that's everything for now. Thank you for joining me in this video. I hope you've learned something, and I'll see you in the next one. We're going to be using functions a lot throughout this course. Hi guys, and welcome back. In this video, we're going to learn about arguments and parameters, which we can use to make our functions generic so that we can use them with multiple different pieces of data. Let's say you've got a car dictionary that contains some information about a car, such as the make, model, the mileage, and the total amount of fuel it has consumed over its lifetime. You can calculate the miles per gallon, which I know is quite a British thing to be calculating, as the mileage of the car divided by the total amount of fuel consumed. Let's imagine that this is a unit in gallons. You can also get the name of the car as the make and the model. So I'm going to create a f string with the make and the model. Finally, we can print something like this car does this number of miles per gallon. If we run this program, you'll see that there's nothing new here. You get Ford Fiesta does 50.0 miles per gallon, and that's all well and good. You know, you can actually put this into a function if you wanted to call this specific code many times. So what I'm going to do is I'm going to put a def statement such as calculate mpg and the colon, and what this does again is it creates a new function called calculate_mpg, then the two brackets at the end, the colon, and all the code inside the body has to be indented. So I'm pressing the tab key when I select all of these lines, and that's going to indent them all. It's going to add 4 spaces in front of each line. Now that we've got that, we can call this function so that it will run. So by pressing run now, the same exact thing will show up because we haven't really changed anything. All we've done is we've put this into a function and then we've called the function which runs the code. So it's the same as before, but a little bit longer because we now have to create the function. If all you wanted to do was this, you don't need a function for it. So we're going to make this function a little bit better. We're going to change this function so that it doesn't always use this data. We're going to change it so that it can use any arbitrary piece of data that we pass to it, given that it has this structure. So I'm going to take this car out of the function, and I'm going to put it on top here. Let's say that. I'm going to make sure to unindent it so it's all good. Now, if we run this again, this will still work. And that is because when you go into the function, and you try to access the car variable, notice that it's not defined inside the function. So Python realizes that maybe it's defined outside the function. So it goes looking to the next block, which is the main application. And it can find the variable there, so it uses that. So that's all well and good. This still works. But once again, we're limited by always using the variable out here. So what we're going to do is we're going to put something inside the brackets. What we're going to put is car to calculate. And then inside the function, we're going to use this variable name instead of car. So I'm just going to expand this a little bit so it's a bit easier to read. What we've got now is that inside the function, we're using this thing called car to calculate. And that is inside the brackets. So what does that mean? Well, it means that when we call this function, as we do here, now we must pass in some data, such as this dictionary, and the value of this dictionary will go into this, which is a new variable that we are creating when we start running the function. So all I'm doing here is I'm calling the calculate mpg function, but now I am passing in a value. I'm giving it what's called an argument. And this argument here is what gives a value to this parameter. So the value you pass into a function is called an argument. The variable that receives the value is called a parameter. So if we run this right now, we can delete this variable, by the way. The exact same thing will happen because now we are running this function and we have this car to calculate variable. And when we run the function, we are passing this dictionary into it. So when the variable accesses the mileage property of this variable, we're accessing this thing here. And when we access the fuel consumed, we're accessing this thing here. This is all well and good, but we are still limited by one thing, which is that we've got this single variable that we can use to call that function. So let's make this program a little bit better. Instead of passing the dictionary in here, we are going to create a list of cars. So here we have a list of cars. We've got the first car, which is the Ford Fiesta that we were using earlier, and then we have another one, a Ford Focus, a Mazda MX-5, and a Mini Cooper. Now we have 4 cars in here, so we cannot do this. The reason we can't do this is because if we put the cars list inside the brackets, the value of the cars variable, which is this list, will be assigned to this parameter. And then when we try to access the mileage property, it was trying to access the mileage property of this list. And again, lists don't have this sort of access. You would have to access element 0 or something like that if you wanted to access a list. This is only applicable to dictionaries, as we know, so we have to access one individual car of this list. So we can calculate the MPG for cars 0, say. and that will once again give us the Ford Fiesta. If we change this to Cars 1, that is going to give us the Ford Focus. If we change it to Cars 2, it'll give us the MX-5. So, this is the perfect place to use a for loop. If we make a for loop for car in cars, then instead of passing cars 0, 1, or 2, we can just pass car. And that is going to print out one line for each car, as you can see there. Something important to know is that this variable car to calculate can just be renamed to car. And I appreciate this will be a little bit confusing. But here's what Python does when it encounters a variable. Here we're using the car variable. So the first thing Python is going to do is it's going to check whether it was declared in this body. And in this case, it was, because it is the parameter. So because car was declared here, it will use this one. If we have another car variable declared up here, then this one will still be this parameter. It will not use this one here unless there is no variable defined there. Then Python will check here, it won't be there, and it will go to the next level. So your variables can take the same name as something that's declared above if you want. It's generally discouraged to do that, so do it with a bit of caution. Here I'm doing it because this car variable that we're declaring inside this for loop is used down here as a sort of temporary measure, so I'm okay with calling this variable car. But sometimes if you have global variables that you want to keep as unique names, you can do that and you can call these variables something else, such as car to calculate. It's really your choice. In this case though, calling it car makes the code a little bit simpler because the other variable name was a bit long. So this is how arguments and parameters work. We've learned how to pass an argument, which is passing a value and putting it inside the brackets, and that the value of this variable will be assigned to this parameter. It can have the same name, and that's totally fine. And if you want to have multiple parameters, such as something like car and intro, say, such that you can print the intro there, then you define them like this. You put one parameter name first, and that is going to be a new variable that gets created when the function gets called, and then a comma, and then another variable that will be created when the function gets called. Now this function needs two arguments because it has two parameters. So down here, you can pass in after the comma an entirely new argument that will now be the value for intro. So this will be the value of that, and this will be the value of that. If we run this, you'll see that every car prints new car in front because that's the value of intro. Hopefully this makes sense. I hope I haven't confused you too much. Functions are going to come in really handy as we develop. And indeed, whenever we're making longer pieces of code, it's often a good idea to split different parts of them into functions so that the code is a bit more readable. Something very important about functions is giving them a name that describes what they do so that when you read the code that uses the function, you can very easily tell what it's doing. If you're not sure what to call a function, don't worry, it's the same thing as naming a variable. It takes time and experience to get really good at it. Thanks for joining me in this video. Hope you've learned something, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to look at return values. And that's because functions can not only perform actions, which is what the calculate MPG function does here. It processes some data and then prints something out. They can also take some inputs and give us some outputs. What that allows us to do is to extract some of this code into a separate function so that they don't get too long. This calculate MPG function at the moment does a bit more than just calculate MPGs. It calculates MPGs, and then it also calculates the car name, and finally it prints it out. So there are a few things going on in this function, and that's usually something that tells you that you can have multiple functions instead of just one. a few things are going on, you can have one function for each thing. Let's make our calculate MPG function actually only calculate MPGs. What we'll do is after the calculation, we will just do return MPG. This is how you can return values, and what that means is whenever this function gets called, you can then assign that to a variable. For example, we could do something like this, and then the value of dividing the mileage by the fuel consumed, which is a float, will be assigned to the MPG variable via this return. We'll have 50.0, let's say as an example. We will return 50.0, and then we will assign 50.0 to MPG. Now, because that's happening, as soon as Python encounters a return statement, the function ends, and none of the other code evaluates. So, what we've done here is we've made our calculate MPG function actually only calculate MPGs. Now we need another function to do the rest of the stuff. So I'll define a function called car name, and it will also take a car, and it will just calculate the name, and then it will return it. Finally, I'll make a function called print car info, which will take a car as well, and it will use these two functions to get the car name and to get the car's MPG. Finally, it will print it out. Notice that this function here does not have a return. So when we run this function, if we were to assign it to a variable like this variable would be equal to the special value none in Python. None just means no value. So all functions in Python return the value none by default, or you can of course just do return none if you want to make that explicit. None has a capital N, and again, it just means no value. What we've done here is we now have three functions. So I appreciate this is a little bit more complicated than it was before. We've got a function that calculates the miles per gallon, and it accepts a parameter, which should be some data, which has to be a dictionary, since we are accessing a dictionary's properties. And this car data has to contain a property mileage and a property fuel consumed. Then it's going to divide one by the other, and it's going to return that value. In the function print car info, which also takes a variable car as a parameter, which should be a dictionary with this structure, it then passes the value of that variable to the car name function and to the calculate MPG functions. Let's take the calculate MPG function as an example for this flow. We will receive the car information in the print car info function. Then it gets passed over the same value to the calculate MPG function, which uses the properties to calculate something. This return value then gets assigned back to the MPG variable inside print car info. So you can see how Python is jumping around. As soon as it encounters a function, it goes and runs the function code. If there's a return, then we can assign that to a variable. So running this function here is exactly the same as just copying this code and putting it there. However, because it has a name, such as car name, it's a little bit easier to read when you're looking at this function to understand what it does. Clearly, this function first gets the car name, or calculates it in some way, then it gets the car's MPG and it calculates it in some way, and finally prints some information out. And you don't necessarily have to go and look at these other functions as long as you believe that it calculates the name and the MPG correctly. But you can do if you want in order to understand how the name and the MPG are calculated. Notice that here at the end we have now got MPG equal print car info, but this print car info function does not return anything, or rather it returns none by default, so this is kinda useless, so we can just remove it. We can just call print car info, and that is going to run through this code here and print the information by using these other functions. I'll also say that it's good form in Python and generally recommended to leave 2 lines between each function definition so you can read through it a little bit quicker. Now this code is getting a little bit longer, but we can still run it and it will print out the same thing as before. Something that my students frequently do is a small mistake, which is to print this function here. If you say print of print car info, what you're doing is you are passing the result of calling print car info to the print function, which is then going to print this value out. The value that will get printed out is the return value of the function. But because this function returns none, what you'll see here is none printed out. So you still get all of the stuff from our previous functions, but now you get none in between each function as well. This is normally not what you want, so just don't print the result of calling that function. You can just call the function and let it print. If you wanted to print here, you can make this return. And then this function will now actually return this string, which then you can print out. If you don't print it out, you won't see anything output in the console because we haven't printed anything out. We've just got some values. If you want to show them, you have to print it out. So if you make the function return something, you can then use that value. If you make the function print, like we had earlier, then you don't have to use that value. Functions can return multiple times. And what that means is, let's say that you've got a divide function that takes two numbers and divides one by the other. But you want to make sure that you can't divide a number by 0 because that's illegal in mathematics. You can say if y is equal to 0, then you can return you tried to divide by 0. But otherwise, we can return x divided by y. This works in exactly the same way that all if statements do, which is that if y is 0, then this code runs. But if y is not 0, then this code runs, and this one does not. Both of them will cause the termination of the function and the value to be given back to the caller, but only one of them will ever run in one function call. So you can have multiple return statements as long as they won't both try to run. So if you have this instead, this if statement will never run, because when this one runs, the function terminates. So having two return statements one after the other is not very useful because only the first one would ever run. So if you put them in an if statement, that's better. Either one will run, but both can run given the right circumstances. So if we print the divide of 10 and 2, you'll see that you get 5.0. But if you print the divide of 6 and 0, then you'll see the string gets printed out. You try to divide by 0. Once again, just to reiterate, if you call these functions but you don't print, nothing will get printed out because these functions calculate a value and give it back to the caller so that you can put it in a variable or do something with it, but you still have to print it out if you actually want to show it to the user. That's it for this video. I wanted to tell you about return values for functions because they really start allowing you to split out your code and move it from one place to another, putting it into functions so that you can reuse them in other parts of your code. As you learn more Python, you will increasingly put code into different functions so that you can use them in multiple places. Thanks for joining me. I hope you've learned something, and I'll see you in the next video. Hi guys, and welcome back. In this video, we're going to learn about default values for parameters. Let's say you've got a function called add, and it takes two numbers, x and y, and calculates a total, and then returns it. Then let's say we call it with the values 5 and 10 and print it out. So if we run this, you get 15, because 5 gets assigned to x, 10 gets assigned to y, and then the sum 15 gets assigned to the variable total, the value of the variable is returned, and then that value is printed out. In Python, you can say y equal 3, for example, and what that means is that if you don't pass in this second value, then it will be 3 by default, so you can call this function with a single value if you prefer. So you can say add and just pass in 5 inside the brackets, and then y, because it doesn't have a value, will take the value of 3. So if we run this, you'll get 8. Notice that you can still pass in a value if you want, and that just means that y will be this value and it will not take the default value. Also, let's take this opportunity to talk about named arguments. In Python, to make calling the function a bit more readable, you can say x equal 3 when you're calling the function. And what this says is x, this parameter here, will take the value 3. Y will still take the value 3 because that's the default value. If you run this, you'll see that the value is 6. You can say something like x equals 5 and y equals 2, and that's also totally fine. Now the result will be 7. And again, what this says is the parameter x has the value 5, the parameter y will take the value 2. Notice that this here is something we're doing when we call the function, so when we use it. And this here is something we do when we define the function. These are called named arguments, and they are there so that when you call a function, it's clearer what each number is for. So here the 5 is for x, the 2 is for y. But when you define a function, y equals 3 means a default parameter. So if you don't pass a value, y will be 3. Even though the syntax is the same, y equals 3 and y equals 2, they do mean slightly different things depending on where you use them. Something important to remember is that you cannot do this. If you do x equals 5, comma 2, you'll get an error. And that's because the argument that doesn't have a name cannot be used after an argument that has a name. So if the first argument has a name, such as x, then all subsequent arguments also must have a name. Otherwise, it will give you the error. The opposite can be done though. The first argument can not have a name and the second one can have a name, and this is fine. So it just means that if the first one has a name, the second one needs to have a name too. But if the first one doesn't have a name, the second one can still have one. So that applies for all the arguments. Similarly, if you just do y equals 2, Python knows that you want the value 2 to go to the parameter y. So instead of 3, which is the default value, we will use 2. That's all well and good, but we don't have a value for x. So Python will give you an error telling you that you are missing one required positional argument. A positional argument is just an argument that doesn't have a name. So here we have a named argument, also called keyword argument, and the x is a positional argument if we do something like 5. So you do need to provide a value for x because it doesn't have a default value. The same thing applies when defining a function, by the way. So you cannot have x equals 5, y because you've got a default value here, but not here. Default values must go at the end. So if one parameter has a default value, all subsequent parameters must have default values as well. So this would also give you an error because it says non-default argument follows default argument. Many functions in Python have these named or keyword arguments. For example, the print function. Say you print 1, 2, 3, 4, and 5. What we're doing here is we're passing the value 1 to the print function, and then we're passing the value 2 to the print function, and then 3, and then 4, and then 5. So we're passing 5 different arguments to the print function. If we run this, you'll see that you get them printed out with a space in between each. But you can actually pass a special argument called sep and make it equal to whatever string you want, and then instead of the space, it will use that separator. That's what sep stands for. So here's an example of one of the built-in functions, print, that has one of these named arguments that you can use as well. If you have a variable such as default y and you want to create a function that uses it as one of its default values, this is highly discouraged. Here's this function which has a parameter x and a parameter y with a default value of the value of default y. What this does is when Python reaches line 3 and it defines the function, it remembers the name of the function, add, and then it also calculates the default value, which is at this point in time 3. So if you do add 2, that means that x will take the value 2 and y will take the value 3. If we run this, you'll see that 5 is printed out. But if you now change default y to say 4, and then you add 2 again, you'll see that 5 gets printed out again. So what this tells us is that when Python defines the function, it also stores the default value at the time. So even if you change the variable that is the default value, it will not change when you use the function. It still keeps the value that was used when you defined the function initially. Therefore, it is highly discouraged to use variables as default values because of this thing. The fact that you use the variable doesn't mean that this value is going to change whenever you change the variable. I'll say at this point, be careful when using lists or dictionaries as default parameter values. That's because, unlike strings and integers, these will update if you change them inside the functions. And this is due to a language feature called mutability. It's not important for you to understand this now, but just bear in mind that lists and dictionaries behave differently than strings and integers behind the scenes. That's it for this video. Hope you've learned something, and I'll see you in the next one. Hi guys, and welcome back. In this video, we'll be talking about Lambda functions. Lambda functions are used to get inputs, do a small amount of processing, and return outputs. Functions can do two things. They can perform an action, or they can return an output, or they can do both. For example, the print function is one that performs an action. It shows something to the user, but it doesn't really modify the data it receives and give you some new data. However, if you have a function such as this divide function, which takes two numbers and processes them and returns some output, this could be a good function to use in a Lambda function. The print function, though, would not be. That is because Lambda functions are used to take inputs and return outputs. If you wanted to rewrite this function, which at the moment is a normal function, into a Lambda function, you can do this. Here we are creating the Lambda function, and we are assigning it to the divide variable. If we do this, we no longer need this. The structure of the Lambda function is as follows, and I appreciate it's a bit confusing because of its short nature and the amount of symbols involved. You've got the Lambda keyword, then you've got a space, then you've got a list of parameters. So these are the inputs to the function. Here we've got two different inputs, one called x and one called y. Then after a colon, you have the return value of the function. So this function here takes two inputs and returns the division of the two. So again, it is identical to this function here, because this one also takes two inputs and returns their division. This one also returns their division, even though it doesn't have an explicit return statement. This is what Lambda functions do. So, because it's got the divide name, you can still call it as you would any other function. Just call it with the brackets and put the values in there, and you get 5.0. Now, something interesting about Lambda functions is what happens if you don't assign a variable to them. Well, Python will create this function and immediately destroy it. If there is no name associated with this function, Python realizes that you can't use this function anywhere else because you have no way of referring to it, so it will immediately destroy it. However, you can call this function like this. This is even more confusing, and I would almost never do this. But here you use brackets to tell Python that you want to run this code first. You create the function, and then now that you have this function, you can use the bracket notation to call it and pass in two values. Remember that this is identical to doing this if the divide function was already defined. But because it's not, you can do this, and that defines the function, and then the brackets signify that you want to call it and give it two values. Now notice that if you run this, the function does evaluate but nothing gets printed out, so you have to chuck this into a print statement, which makes it even more confusing. Now you get 5.0 back, but this code is pretty crap code, because there are a lot of brackets, symbols, things going on in a single line that frankly don't have to be in one line. You could define this in another line and make this a bit more readable, make it a bit clearer what's going on. So what is the purpose of Lambda functions? Lambda functions can, at times, provide more simplicity to code. However, just as you've seen there, they can also at times make it more complicated. So you do have to be careful with Lambda functions when you're using them. Let's look at an example. Here we've got some code where we define a function called average that takes in any arbitrary sequence and returns the sum of its elements divided by the length of the sequence. So, for example, if we iterate over our list of students, we can then call the average function with each student's grades. And what that is going to do is it's going to take these grades, and then these, and then these, and then these, and it's going to calculate the average of each, and it's going to print it out. Pause the video for a moment if you need a bit more time to look at this code and thoroughly understand it. Just as we have defined our average function here, we could make this into a Lambda function if we think that's going to make things simpler. I think that certainly it's not going to make them more complicated, so maybe you could do something like this. This behaves in exactly the same way because this is a function that still takes in a parameter and then adds it all together and divides it by its length. However, it's fairly uncommon in Python to use Lambda functions in this way. That's because when you have a function that's sitting on its own and you're assigning it to a variable, you might as well just define a normal function. It makes it a little bit more readable. So while you can do this, and this is one of those use cases where you might use a Lambda function, there are better scenarios for using Lambda functions. So we're going to look at some of those in the next video. For now though, I just wanted to tell you about the Lambda function structure and syntax, which is the Lambda keyword followed by any parameters, then the colon, and then the return value of the function. And remember, Lambda functions are used for getting inputs and returning outputs, and they're not used for performing actions, such as what the print function does. Thanks for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video we're going to learn about first-class functions. In Python, functions are first-class citizens, and that means that just like strings and integers and anything else really, we can assign functions to variables and we can pass them in as arguments to other functions. We're going to learn more about doing just that in a later video in this course, but for now let's focus on assigning them to variables and using them as values in lists and things like that, and why that can be useful. Let's get started. Let's say that we've got a greet function that prints hello. You know that of course we can call the greet function and that's going to run it, and the calling of the function happens when you use the brackets after the function name. So what happens if you just use the function name? Well, we know that that's not going to run the function, so we get no output. But this is still valid Python syntax. What this tells Python is that we're talking about this function here, about the value of the function itself. We don't want to run it, but we are talking about it. We are referring to it. When we have a value, just as a number, a string, or anything else, including a function, we can assign it to a variable. We can say this name here, this hello name, is now a name for the value that this references, and that is the function. So now after this line, hello and greet are the same value. And therefore, that means that we can run the hello function. And you can see here that that's going to print out hello. This is what I mean when I say that a function is a first-class citizen. You can assign it to variables, and as we learn, you can put it inside lists or dictionaries or anything else. Like I mentioned earlier, you can also pass functions to other functions as arguments, but we won't look at that until much later on in the course. Anyway, this is not a particularly useful example, so let's move on to a more useful one. Imagine that I want to create a function that calculates the average of a sequence. So for example, def average like that takes in a sequence and then returns the sum of sequence divided by the length of the sequence. Pretty normal function, we've seen this before, so we can recreate this as a lambda function just for shortness, and we covered how to do this earlier on. This would be lambda sec is a sum of that divided by that. So this is the same stuff, just this one is as a lambda function. The reason why I'm making this a lambda function and not a normal function is just because it's a little bit shorter, and these other functions that we're going to create here are also good lambda functions. Just like that. So now we've got three functions, average, total, and top. The average one calculates the average, total calculates the sum, and top calculates the maximum value of a sequence. Now, let's say we've got a list of students that I'm going to paste in here. We've got a list of dictionaries, and each student has a bunch of grades associated with them, and that is a tuple of numbers. So that's, let's say, the grades that they got in an exam. Let's use these functions now to operate on these grades. How we do it is we'd say for student in students, we're going to get the name as student name and the grades as student grades, just like that. Then we're going to print out the student name. And finally, we're going to ask the user what they want to do. Do they want to calculate the average of their grades, the total of their grades, or the top value that they got? So we'll say that the operation is input, and we'll ask them to enter either average, total, or top. Sorry that this has gone into two lines there. I'm just going to move that a bit. There we go. So now we're going to ask for each student what the user wants to do with their grades. Now comes the simple part, which is to write an if statement that deals with this user input. We know how to do this. We've done this a lot of times before. If the operation is equal to average, then we will print the average of grades. So nothing new here. We're saying that if the user entered the word average exactly, then we're going to print the result of calling the avg function, which was defined up here, on the student grades, which are each tuple for each student. So let's just run this at this point. And of course, if we enter average, then we get the average grade for Rolf. If we enter average again, then we get the average grade for Bob. If we enter something else, like total, we get nothing because we haven't coded that part of the if statement yet. Let me stop this here. If we completed the other operations, they would look like this. If the operation is total, then we print out the total. Otherwise, if it's top, we print out the top. Nothing new there. So how can we make this code a bit better, a bit shorter, a bit simpler? The first thing that we have to realize is that we're asking the user to select what they want to do using code language, if you will. And so what we're doing here is we're giving the user a few specific options, and then we're selecting one of those options that matches something in our code, a function that we want to run. Therefore, if we can say select whatever the user entered and run the function associated with that, that's going to make our code a bit simpler. So how do we create associations in Python? We use dictionaries. So we'll create an operations dictionary, and we'll associate each thing that the user can enter with one of the functions that we defined above. Just like that. So now we've got an operations dictionary that maps user inputs to functions. And once we have that, all we have to do is get the operation function by saying operations operation. So that is going to go into the operations dictionary and get us the key that matches the user's input. So if they entered average, then that's going to get us AVG, the AVG function. not the result of running the AVG function, but the AVG function itself. And so on with the others. Therefore, once we have the operation function, we can call it with the student grades. So now if we run that, you'll see that we can enter, for example, top, and we get 100, which is the top grade for Rolf. For Bob, we can enter average, and we get 76, which is their average. And if we enter something completely random, like something else, we get an error. Now, this is the compromise that we're making when we use a dictionary instead of an if statement. With a dictionary, we're going to get an error when we try to access a key that doesn't exist, but with an if statement, we would not get an error there. What we can do is we can use error handling to catch the error and print a nice error message instead. But we're going to learn how to do that later on in this course. Something else to remember is that we can make this code even shorter if we want, and if we're comfortable with that, by inlining the Lambda functions into this dictionary. I'm not entirely sure how I feel about this. I think it's getting a bit complicated, but you can do it if you want. With these functions that are relatively small and simple, I think it's probably okay, but if it gets more complicated, if your functions are doing more things, you'll definitely want to separate them out and use the operations dictionary to sort of compile them into one readable block of things that a user can do in your code. Something else that I wanted to mention at this point is that we've got here sort of like a proxy function, something that we define as a function that just calls another function with the same arguments. So you can see that our function here is just receiving an argument, passing it to the sum function and calling that. So instead of doing that, we could just use the sum function directly. Why? Because now when we access the sum function through this operations dictionary and we call it, we'll essentially be calling sum of grades, which is what we were doing before, but just we've removed one layer of our own functions that wasn't really doing anything. So that's just the small optimization thing you can do there. You can use sum and max directly instead of coding your own Lambda functions. Of course, we can't do that for this one because it's not just passing the argument to another function, it's actually using two functions there, so we can't do that in there, but we can simplify those two. Now, inlining the functions makes more sense because we're just using some built-ins, we're not really adding any complexity. Alright, I hope this makes sense. I know it's a little bit tricky to deal with these first-class functions, but just remember, any function is just a value. And it just so happens that if you put a pair of brackets after its name, it's going to run and it's going to execute the code inside it, but you can still refer to them by name and use them as values. So I hope this has been useful, and I'll see you in the next video.